If you believed tech headlines over the past decade, then by 2026, your phone should last a full month on a single charge, and electric cars should already be cheaper than gasoline cars while driving over 500 miles per charge. None of that happened. So what's the truth? Is the battery industry progressing too slowly, or have we been misled? As a former energy systems engineer, I'll say this bluntly. Elon Musk does not hate innovation. He hates when people confuse a battery that survives 100 cycles in a lab with one that must endure 3,000 to 5,000 cycles in the real world. That's why he openly calls many so-called miracle batteries garbage. A cell that performs well in a test chamber doesn't mean it can survive 104 degrees Fahrenheit heat constant vibration, high-power fast charging, and a defect rate below 1% when produced at millions of units per year. The deadly gap between the laboratory and the factory floor is where most battery hype goes to die. In a tightly controlled lab, I can build you a lithium metal cell today with 3 times the energy density of the battery in a Tesla Model Y. There's no magic involved. It's just basic chemistry. But here's the question. Every press release avoids. How much does that cell cost, and how long does it take to make? The answer: about 3 days of manual labor and roughly $5,000 for a single cell. For that same cell to matter in the automotive industry, I'd need to manufacture it in 3 seconds at a cost of around $5 per cell. The gap between those two numbers isn't a technological hurdle. It's a graveyard where thousands of battery startups have already died. That's why Elon Musk kills hype. A battery that cannot be manufactured at industrial speed is, economically speaking, worthless. If you want to understand how brutal this reality is, look directly at Tesla's very real struggle with the 4680 battery. It's the perfect example because it proves one painful truth: even Tesla can't cheat the laws of physics. In 2020, Tesla unveiled the 4680 cell and promised a revolution. Dry electrode coating was advertised as eliminating massive drying ovens, reducing factory footprint by up to 90%, and cutting battery costs by 50%. On paper, it was beautiful. The idea was to turn binder materials into a microscopic fiber network that could hold active material together without toxic solvents. On PowerPoint slides, it was flawless. But when that process left the lab and entered the gigafactory, reality hit hard. To coat dry powder onto a moving foil at industrial line speeds requires enormous shear forces. The result: the coating tore, wrinkled, or became uneven. Those tiny imperfections created hotspots, internal shorts, and serious safety risks. Tesla spent years, not months, trying to fix this. They burned billions of dollars and delayed the Cybertruck again and again, simply because they underestimated how hard it is to scale a new process. Musk's current skepticism doesn't come from arrogance, it comes from scars. He once believed his own promises, and the cost was very real. Musk understands a cold industrial rule: until you achieve over 95% yield on a 24/7 production line. You don't have a product, you have a science experiment. If Tesla, with nearly unlimited capital and talent, struggled for 4 years just to mass-produce a larger cylindrical cell, why should anyone trust a press release from a startup that has never built a factory? This is where we enter the media danger zone, called solid-state batteries. The press calls them the Holy Grail. Absolute safety. Massive range, zero fire risk. The theory is sound. But ask any materials scientist about stack pressure, and the excitement evaporates. Lithium ions have mass. When a battery charges, ions move and the anode expands. Liquid electrolytes can accommodate that expansion. Solid electrolytes cannot. The rigid interface cracks, delaminates, or fractures under stress. To keep the cell from destroying itself, you must apply tens to hundreds of atmospheres of pressure. Ask yourself, how do you design an electric vehicle that must carry a steel structure as heavy as a hydraulic press just to keep the battery alive? The weight of that pressure system wipes out the energy density advantage entirely. You end up with a lighter cell inside a heavier box. And that's not the end of it. Solid electrolytes also suffer from lithium dendrites, microscopic metal spikes that grow through the separator like tree roots breaking pavement. Once a dendrite bridges the gap, the battery dies instantly. Companies like QuantumScape are doing serious work. But they're fighting fundamental material mechanics, not a simple optimization problem. That's why Musk chooses boring chemistries like LFP, slightly lower energy density. Yes, but no extreme pressure, no fragility and infinite scalability. In industry, what survives isn't what's perfect, it's what tolerates mistakes. Beyond physics, there's also economic damage caused by hype cycles, often called the Osborne effect. When media constantly promises 1,000-mile range and 5-minute charging next year, what do consumers do? They stop buying current vehicles. Why buy a 300-mile Model Y today? If a miracle is supposedly coming tomorrow, the result is frozen demand, collapsing cash flow, and less capital for real improvements. Musk understands that the energy transition is a race against time. We can't wait for a breakthrough that may never arrive. The truth is that battery progress is logarithmic, not exponential. A 5% annual energy density improvement is already a major win. There is no Moore's law for chemistry. Electrons don't behave like transistors. Promises of giant leaps only create disappointment and convince the public that EVs aren't ready, when in reality, they already outperform internal combustion engines on almost every metric. Worse hype focuses attention in the wrong place. The real bottleneck in batteries isn't cell design, it's mining and refining. We lack battery-grade lithium, battery-grade nickel, and refining capacity. You can invent the best solid-state battery ever, but without lithium hydroxide at scale, it's just a drawing. That's why Musk focuses on supply chain integration, refining lithium in-house, producing cathodes, internally optimizing voltage architecture. The magic isn't in new materials. It's in turning rocks in the ground into batteries at a cost that competes with a gallon of gasoline. So what's the conclusion? It's time to accept boredom. The future of batteries doesn't look like science fiction. It looks like a metal foil moving 30 feet per second without wrinkling. It looks like structural batteries forming the vehicle floor. It looks like moving from 400-volt to 800-volt systems to reduce copper usage and losses. None of that is sexy. But added together, it becomes a revolution. When Elon Musk sounds irritated by the latest battery breakthrough, he isn't being negative. He's saying what every engineer knows: a prototype is not a product. The hard part isn't making one battery. The hard part is making 1 million identical ones cheap, durable, and safe. That is the message Musk has been trying to deliver all along.